functions in the logistic differential equation. So hold that thought, we'll come back to it. A logistic differential equation, and kind of where it comes from, I'm going to pull some knowledge. You remember we learned exponential differential equations in Unit 6. And so we learned if we had dp over dt equals k times p, that was going to cause when we solved that exponential function, we were going to get a PERT formula problem. I remember that happening. However, in a lot of exponential growth situations, there's a limiting factor in the environment. Those of you who've had a biology class, even maybe a chemistry class, know that certain places can't hold over a certain population. So growth will happen exponentially for a while, but then there will be a leveling off point. You'll know what I'm talking about from biology, how that happens. That type of function is called a logistic function. L is considered the limiting factor. I think on the next slide it might be called M instead of L. Don't get caught up in the letters, but that letter is called the limiting factor. In this situation, the rate of increase or decrease is directly proportional to both P and LP. So you get a differential equation that's a constant times P times the limiting factor minus P, where P is the population. And it says oftentimes we'll want to find a second derivative to find out what time P is growing fastest. There are a couple of things we're going to look at. This is the logistic growth equation. Now sometimes they will have us solve it. You'll notice this is the bell ringer. Other times I'll have us answer other questions about the logistic equation. And so the first question that is asked often is, what is the maximum carrying capacity of the situation? So this one is mountain goats. The growth rate of the population of mountain goats in the New Game Preserve is modeled by this differential equation. What is the maximum carrying capacity? If you know the logistic curve, that's just a matter of knowing what the 30 means, right? Because 30 is the limiting factor, and what that means is the maximum goats this preserve can hold is 30 goats. So the answer there is 30. So there's no calculus involved in that. You just know what the function means, know what each part means. That piece on your gateway that you didn't know what was talking about, now you know. Do you know which one I'm talking about? The one that said, explain or state the logistic differential equation and what each letter represents. Now you know. What is the goat population when the population is growing the fastest? Any ideas on that? I'll give you a second to think. You're probably still writing anyway, so I'll give you a second to think, write, all those things. What is the goat population when the population is growing the fastest? And you could go ahead and see if you can answer what is the rate of change of the goat population at this point. The 0.008 is a constant. The P is the population of goats, and the 30 is the what in science you probably heard is the carrying capacity, or the limiting factor on the growth. If I want to know when the population is growing the fastest, what is that a question about? The second derivative, isn't that when the rate is the highest? Well, I have the rate here, so to find the maximum rate, I need a second derivative, so equals 0. Do something like that. So what is the second derivative? How would you even do that? last right, B left? Do what? You shouldn't either way. You distribute it. You got negative 0.008 times 30p. The derivative of that is a constant. So then the other part is negative 0.008 times p squared.
And that I did 60. Oh wait, that's
No. This is the second derivative already, because the first one was already the first derivative. Do some simplification, so if you had distributed first, you wouldn't have to do the simplification. I always like using algebra first, as you know, so. What is 30 times 0.08?
0.24.
0.24? Minus 0.008. Right? So we do get a constant. No, those are both negative. So negative 0.016, is that right? Okay. What will I do to find the maximum? So that equals 0. Negative 0.24 divided by I guarantee you if this is the problem, it is a calculator problem, so you do not have to do all of this in your head.
0.016. So I'm going to get this.
15. A little bit.
You just move them around and it's like
Okay. So let's talk about this. If the carrying capacity of the environment is 30, does it make sense that when we get kind of to half of that level that your population is going to have to start slowing in growth? So it kind of makes sense anyway, but if we wanted to really cover all of our bases, how would we know that that is in fact a maximum and not a minimum? Yeah, you could do some kind of test. Probably the fastest test would be a second derivative test. I don't have the second derivative of the first derivative, so I would have to do one more derivative, but it would be at negative 0.016. You see how fast I can do that derivative? Because the derivative of this would be negative 0.016, which means I do in fact have a concave down graph, which means I do in fact have a maximum. So if you wanted to use the second derivative test to verify that that is in fact the maximum rate, you could. Any questions about that one? The slope field below is the graph of the given differential equation.
Wait, so B, what did we find?
Oh, sorry. That is the goat population when the population is growing fast. You're right, I'm skipping C, so I need to do part C. So it's the goat population, because P is the population. And I found when the derivative was a maximum by looking at the second thing. So I do need to answer C. What is the rate of change of the goat population at this time? So if I'm asking rate of change, what is that? The first derivative. So I want the first derivative at 15. So I want dp dt when p is 15, which is, someone with a calculator, give me that number. Well, what do I put in? 2 times 15, so that's 30 times negative or positive 0.08. 1.8. 1.8, and that would be, what would my units be? Goats per time, and I don't know, it didn't tell us what time was, maybe days, maybe, I don't know. need to know this in BC calculus, but your calculator will graph a slope field. The TI not will graph a slope field if you put it in differential equation mode. That's not cool, but you won't need it, but it's cool anyway. So this is the differential equation. If 3 male goats and 3 female goats, 6 total, were introduced when the game preserve started, sketch the number of goats over time. So 6 goats were introduced when the game preserve started. I think these are just counting by ones, don't you know?
Yeah.
Sketch the graph of the number of goats over time. This is an initial value problem. Gives me the slope field, gives me an initial value, and I can sketch the graph. So Grant, essentially what a slope field is it's a graph of all the slopes at all the different points. You know those weather maps that have the arrows on? I'll tell you how the wind. So imagine a slope field being that, and then drop a leaf somewhere, and where the wind would carry it would be that curve. We're going to follow that slope field up. Any questions about that? Do you see why it levels off? It has that limiting factor where that slope is 0 to slow the growth down. Any questions about that?
Or have a
Theoretically, but no one really knows what the carrying capacity of the Earth is.
So could it start low as well?
It could. It could be a logistic equation that is some kind of decrease that has a leveling off of maybe, or you remember from way a long time ago, we did like cases of AIDS. Okay. I imagine something like that would have a level off where you're always going to have some cases, but you had a steep level off when people realized how you got it and all that stuff. Things like that maybe that you could also have on harmony decrease. So here's what the donor was, and it's a horribly difficult differential equation to solve. And we love differential equations show up on the AP exam, right? What do they mean when differential equations show up on the AP exam? What have we learned that they mean? Lots of points, 6 of them. Almost every time there's a differential equation, we get 6 points, right? This is the one we kind of hope not to see, but it might show up also on the BC exam compared to the AP exam. Now, a lot of times they test logistic growth. They test, can you plug in things and whatnot. But then every now and again they'll test if you can solve a differential equation. We will learn also what the solution looks like. So, first thing we do is separate the variables. Grant, this is for you. So I'm going to move the dt over. I want all the p's on the left-hand side, so I'm going to divide by the 0.008p and the 30 minus, right? And I'm going to anti-differentiate. Luckily, it is already factored for me. If it weren't, I would need to factor it. And then Grant, to undo a derivative, we're going to integrate both sides. How many points? Because Grant won't know this. You tell him, how many points would this get me on an AP exam already? 2, probably. Separate the variables, anti-differentiate, right? Now, if we anti-differentiate correctly, then you're up to 4, right? Out of like 6. So, just knowing the setup of these gives you lots of points in the AP exam. So, the right-hand side is easy. Everyone agree right-hand side is easy? Antiderivative of dt is just t plus c. The left-hand side, not so much. What is it? Yeah, but what? This.
We have to do the partial fractions.
Partial fraction. I think the only way to do it is partial fractions. Then to do multiplication, we have a product rule for integration. And it's always be partial fractions. So I have A over 0.008 P plus B over 30 minus P. Everyone agree? Or actually, you can do this however you want. I don't know. However you want to do that's fine. You can leave it in. Constants are kind of nice to just move out of the way and save yourself a little. Does everyone agree with that? Just makes your numbers prettier. Anyone? And did I lose anyone on that? On how we can pull that constant out in front of the integral? And so I get 30 minus P here and P here. Any questions so far? A times 30 minus P plus B times P equals 1. What would I plug in for P to make this efficiently go efficient with the heavy side method? I plug in 30, and when I do, I get 30B equals 1, or B is 1/30th. If I plug in 0, I get A times 30 equals 1, which means A is also 1/30th. Questions so far? Will you grab one of these and pass them around? So I have the integral 1 over 0.008. Another thing you could have done that probably would have been smart, you could have left the 0.08 on there for T. If I were smarter, maybe I would have done that. You can have to do it. However you want. So we have 1 over 30 divided by P plus 1 over 30 divided by 30 minus P dP. Now we are going to anti-differentiate. 1/30th natural log of the absolute value of P. What's 1/30th what? It's actually not positive. Why is it minus? There's a negative P, so chain rule involved there, or undoing a chain rule. Really, you need a U substitution. You might be to the point where you can notice those negatives okay without doing a U substitution. You might not. That was fun. They did. 0.6, I believe, was it 0.6? Is that correct?
Yes, 0.6.
Okay. All right. Any questions before we start? I do want to find C. By the way, Grant, you get a point usually for putting a plus C, and then you get a point for solving these differential equations. 6 points in there somewhere. The minus B. So when you do the antiderivative, you have to really need to use substitution. The 30 minus B. Because the derivative of 30 minus B is -1. Or if you can kind of think of the antidifferentiate, you have a -1. So one of the two ways. And it is okay if you need to stop and do a substitution. Okay. I'm going to go ahead and plug in 6 for P. Like I said, if you wanted to, just to simplify your life, you could write this.
So it's the 1 point. If the 1 divided by 0.08 plus everything.
It is. If y'all don't mind, I'm going to move it over here. Is that okay with everyone? Two things you could do. You could do 0.08 times C, or you could just call this a different C. It's still a constant. You would put the 0.08 there to begin with. You just have to say. Doesn't matter. Okay, I'm going to put 6 in for P and 0 in for T, correct?
Mhm.
I would remember. But anyway, write that down for a second. P0, yep. So 1/30th natural log of 6. You notice I dropped the absolute value.
Teachers and students, just a reminder, if you park at stadium, that your car must be removed to when the bell rings. We do have a home football game tonight, and that is reserved parking. So when the bell rings at 3:05, if you park at the stadium, you must move to another location.
And you could stop there, but just for simplification purposes, isn't this 1/30th natural log of 6/24? I don't know how I got that. Combining two logarithms. So now I can rewrite my equation. I told you it wasn't pretty. Rewrite my equation as 1/30th natural log of the absolute value of P minus 1/30th natural log of 30 minus P equals 0.008T plus 1/30th natural log of 6/24. You could go ahead and write 1/4 if you would like. Up to you how you do that. And I need to get P by itself. What's the first thing you would do?
Multiply by 30.
Multiply everything by 30. I agree. You could have actually done that a long time ago if you wanted to. At some point you need to. So I'm going to get the natural log of, and I am going to get rid of the absolute values at this point, and it's because of the initial value on it. Do you agree that my population is not negative and it's not bigger than 30? You can kind of have told that from the slope field. So because of that, I don't have to worry about the absolute values at this point. What is 30 times 0.008? 0.24T plus natural log of 4th. You might hate me after this. No, it's not. I have to get rid of the natural logs. Oh, y'all are. The good news is there's not a lot of these that you have to solve them completely out. Good news. Bad news is it could happen. Good news is most likely. So now what do we need to do?
We separated cut around multiply so you can get the
Okay, you can do that. This is e to the point 24t times e to the natural log of 4th, which is 1/4 e to the point 24t. It does simplify your life. It doesn't finish the problem. It does simplify your life slightly. Cross home. Ouch. I'm going to go ahead and distribute. So I'll get 30/4 e to the point 24t and minus 1/4 e to the point 24t times p. Add the part with the p over. Get all the p's on the same side. Factor out a p. I know I'm going to.